Hello, I'm playing with some more junk again, and this time it's a follow-up video from the blood gas analyzer because I saw that I misinterpreted some of the devices here. For example, these light sources where I thought they're doing analyze here, they're blowing gas in, getting light out. No, that's not true. That's only a light source. This one also. Then this one is not only mirror, and that is certainly not only electrical connector, as you can see here on the other side. And a little printer. Well, let's start with that one. I find this one is really cute. It's a thermal printer. It uses thermal paper, so no ink is needed inside the printer. It just heats up the paper and that gets black. It has a special chemical treatment on the surface. There's a lever to move the paper freely, and of course there is the missing knob to advance the paper. There is only one connector for the stepper motor that advances the paper, and one big flat cable here that goes to the thermal head. That's the white strip here next to the paper. Maybe we can see that a little bit better. Yes, a little bit. Can see that ceramic strip here that goes over the entire width of the paper, and if you apply voltage it prints a dot. You advance it a little bit with the stepper motor, prints another row of dots, of course all dots in a row together. It says 130 ohm, so that's the resistance, I think, of this heater element, or of the heater elements. I don't know how many there are in this row, but if you want to look at, there is a part number. Maybe we can find something. Motec. Well, that's only the label for the stepper motor, so I just wanted to show that because it's really nice little printer here. Goes with standard thermal paper, and maybe I could use that again somewhere. Maybe there is even a driver for that, maybe an Arduino shield, who knows. It shouldn't be too complicated to drive. Okay. Next is this mirror thing here, which is clearly not a mirror, as you probably can see in the reflections. I hope you see that as good as I can. And if I turn that, we have red, yellow, green, blue, purple, white, yellow, green, blue, and so on. So that's a diffraction grating. Is that correct? Grating? Okay. Grating? Grating. Okay. And it's basically the same effect as you have on a CD. A bunch of very narrow lines are etched into this glass, or well, maybe etched, maybe laser painted somehow. Like on the CD, where you have all these spirals that are very close together. If you hold it in the light. I don't have a CD right here. Okay, but you know what I mean. And that's the same effect here. We have an arrow that indicates the direction of, well, of the spectrum you get. So if I turn it that way, yeah, it doesn't work. So the spectrum goes in this direction, in this direction, in the direction of the arrow. Okay, let's see if we can capture that a little bit better. Okay, I think that's about the best I can get. Problem is to find the brightest spot of this torch here. But I think you can clearly see there is a spectrum. We start at the deep violet, blue, then comes something that looks white, then yellow. The difference of the spectrum that you get from a triangular prism. On a prism you have a spectrum that looks like a rainbow, goes from blue up to red. But here it seems you have some white in between. And you also have multiple reflections. You can see it here. There's the first red dot, then another red dot, another red dot. Then here comes the main spectrum, and then that was it. Okay, interesting little mirror. And here it is how it looks on the wall behind the desk. It looks like two spectrums, one on the left from blue to red, then a dark spot, and again from blue to red, and a little bit something on bottom and top, but that's not clearly visible which way it goes. This has to do with the lamp that I'm using, because I'm using a Maglite, and Maglites usually have a dark spot in the center, and well, that's the most uniform beam I can adjust with my torch. Alright, next thing are these two light sources, which I confused with some kind of analytics chamber. There's a clip. If you unlock that, you see there is the light, the fibers that are going into this plug here, and that's only a plug for the light. There is no hole for gas or anything like that. And the reason why they put the light source in the back of the device was simple: to keep the heat away. Especially here we have a halogen lamp here. That's a normal incandescent lamp. And by the way, this tiny little lamp here, which seems to be nothing special, costs 150 euro. I found a spare parts price list in the web, and 150 euros. I don't know how often you have to replace that, maybe not so often, but yeah, pretty expensive. But you have to see there is a special socket, but well, that's almost everything. There's a pin, goes into that groove here, and there is a ball inside with a spring that pushes the entire assembly here into this V-shaped cutout here. So that means this bulb is exactly at the right place to shine its light through this fiber here. That can be unscrewed, and it has a similar connector, and you can see how the fibers here are polished on that side, and here I just cut the fibers apart. Okay, so also no gases go inside, because the reaction chamber, or well, no, not the reaction chamber, but the analysis chamber, that's this part here that looks like a switch of some sort, or I assumed it is a heater, but it is in fact where the gases go in, where the light shines through, and you can see that here. There is a window where light goes through, and the cavity here is filled with gas. And there are two different filters. You can see a difference here on the camera, and also by eye you don't see it, but there is clearly a filter, or maybe a on-off filter or of some sort. And there is an output, goes to another fiber, and then they analyze how much light is absorbed by the gas. And because we have different light sources, we can do this test with different wavelengths and detect different gases. Okay, let's have a look inside. I already showed you the expensive light bulb. There is the fiber. I don't know why they used such a wide hose for the few fibers, but well, that's how they do it. Maybe it's a little bit more flexible. So that's only a mechanical part that adapts the whole thing to the fiber. Then we have a lens. Oops. A spacer, some more washers, some kind of filters, another spacer, and another lens, and a spacer, and another lens. So that's the whole, everything that is inside this. So they basically focus the light to match this fiber here. And there are two different filters. Let's see if we can see that. So one lets through blue light, and the other one is a little bit greenish. Well, they probably both look a little bit green. I don't know, maybe that's some sort of infrared filter, but I'm not sure. But it's certainly some sort of filter. The other light source here, I have to adjust my light, has a different kind of bulb. It has something that looks like a neon bulb. You can clearly see the two electrodes. And it also has an inverter, so we go in with DC voltage to that. Maybe is it some kind of DC converter chip, driver transistor, a coil, a diode. And finally, we have a higher voltage to drive this neon bulb. And I just found out that it works with about 20 volts. I started with low voltage, like 5 volt, nothing happens, 10 volt, nothing happens, 15, 20, okay, with 20 it starts working, and I show you how that works, or how good that works. So I don't want to hold it in my hand because I don't want to get a shock. I'm not Electro Boom, he loves that. Okay, that's it. Power on, power off. And the voltage is about, let me see that again. The interesting thing, it's about 105 volts DC, and they are operating this neon bulb with DC, and you can see that. I hope you can, if I manage it to not interrupt the power. You see that only one electrode is lighting up. That means we have a DC voltage, and if the polarity would be the other way around, the other electrode would light up. And with AC, of course, both electrodes are on. Okay, and that light, there's certainly, oops, I have to adjust the camera or I'm talking with you blind. So there's certainly some other lenses here, and that focus that tiny amount of light into this fiber, and that of course has another wavelength than the light from the halogen lamp here. Yeah, so we probably have a whiter and a yellower light to find out what gases we send through this thing. But that's not all. I already popped it open, and we can see there are 1, 2, 3 ports for hoses, and there's another port for hose connection. And of course everything is riveted together. Normally that's only a piece of metal. And to see what's inside here, there is not much. There is one hint that tells me, or that told me, why this cannot be the cavity to measure any gas, because they say in their product description that the unit only needs, I don't know, 100 microliters of fluid for a complete analysis, and with 100 microliters you cannot fill up a large cavity like the other one, but you can fill up this super small cavity. So that's the thing with the filter. You can see there is a piece of glass glued to one side, and the rest is just clear plastic. It has a smooth surface on this side. And here you can see that micro cavity thing. So inside this white circle here, this oval, that's a gasket, and they only fill this part. There is a hole here and a hole there where gas comes in and goes back again, and then they shine light through that, and that's it. I will show you that later under the microscope. So it's certainly pretty and beautiful. So there is one layer of plastic that may be an electrical insulation. Then there is a rubber gasket. It's just a piece of soft rubber material, and here we see small channels that come up from here, a hole, another hole, so the gas goes up and down to the other side, to this side, to the other side. And here is a little bit more of that. And of course here are electrical contacts and a tiny little chip. Okay, let's see what's inside. So I hope I don't spill it like I did when I tried it the first time. Yeah, I already did. So it's almost impossible to disassemble without damage. But in this case it's not so bad because, yeah, it's junk anyway. By the way, this whole thing is changed together with the measurement cassette, and the measurement cassette you can buy for 250, 500 or 750 measurements or analyses, and then you throw that away and buy a new one. Okay, what we have here are tiny little square ceramic plates that have contacts on one side and something on the other side, and they are all a little bit different. So they all have different markings like 3I, 6I, 4C, there's another 4C, there's a 5A, and because you cannot see that here on the video, I will show you that under the microscope. Okay, and what we see here is this optical analyzer chamber. You can see we have an input or output port that goes through this hole, fills that cavity here, goes around like something and goes back that way. Maybe it's also the other way around. Above that we have this filter unit. You can see there is a glass glued on top of this plastic device, and the position is either here or here, depending on if you slide that in or out. Okay, let's have a look at this tiny little sensor elements here. It's interesting, there are all kind of different patterns here. There are two identicals. Let me see if I can get that a little bit sharper. Yeah, maybe I have to turn that a little bit. Okay. Yeah, so that's the best I can do. I'm recording, hopefully. So we have 6I, we have 4C, then we have 1E. So, and that's the side where the gas goes through or over that. So that's the plastic part. That's the side that is in contact with the with this sensor element. So gas comes in here, flows over here and goes back to the other side and comes here in for the next sensor, goes out to the other side. That looks almost identical here. Then we have these long strips, and that's a little bit strange because I can't see what it actually should be, so I broke it here. So it looks like just a piece of ceramic strip with a layer of silver foil here. You can see that, you can peel it off. Maybe it's even platinum, maybe. Don't know how to test that right now, but I don't know. So we have this silver surface and we have a white surface. And this does, well, I have no idea what it does. Maybe it's connected electrically somehow. One thing I thought is it's probably a heater that heats up the gas a little bit before it's analyzed. Or maybe it's some kind of piezo transducer that acts like a tiny little pump. So what else do we have? 5H. Okay. Then we have a 5C. That looks similar than the 5A, but it's probably another chemistry. Then we have a 5B. That also looks similar. And I guess somewhere in the factory, some people have to assemble that, probably manually. The 6F looks relatively empty. It has contacts. The contacts are used. You can see the marks here. They have a counterpart, that a spring that contacts it, but I can't see anything between that. There is another empty one. It's called 6E. Looks exactly the same, but it seems to be a difference, at least in the name. And then we have that chip thing here, and I would say that's just a tiny little EEPROM or something that probably stores the number of cycles that this cassette already had, so the lifetime, or maybe just a serial number or a type number, so that the unit knows what cassette is actually inside and if it's still valid or not. So that's another part. Then we have that thing. It's also not so interesting. So I think the most interesting is probably this one. 1, 2, 3, 4. Does it have 4 contacts? Yes. And there is also, that could be ground and that could be some kind of guard screen or shielding. Yeah, I think they are coated with some specialized chemicals to react to different materials. So, and that's the gasket, just a piece of rubber with the holes, so the The sensors, they lie on top here and then get the gas that is to be analyzed through the holes. Let's see if we can get a little bit closer. Okay, so where are the interesting bits? That's not really an interesting one. That one has a lot of gold on it. That one has 2 dots and maybe a small wire here. No, I can't see that. And we have a large black blob. Let's zoom in a little bit closer. Okay, that's the 5H. That's the 1E. Here you can see the pattern where the gasket, the opening of the gasket was. So I'm not telling any rubbish. That's in fact as I said. That one is a 4C. So if someone knows what all these letters actually mean, what the 4C sensor does or does not, let me know. That's the 5B, which is almost the same as a 5A. So it looks like these two are connected. That makes not so much sense. So here we have again one with this strip in the center. Oh, maybe that's the other electrode. And here we have another electrode, and together they form some sort of capacitor. This one is in length direction and this one is in the other direction, 90 degrees to it. Yeah, it really looks like there is a silver track, and that's something like a short circuit, but yeah, I have no idea. It's interesting to look at, but it's quite a bit difficult. So you can also see there is something like a yellow layer around here. I hope you can see that too. So there is, well, there must be something, because only with these golden tracks here it cannot sense anything else than maybe moisture or something, but then you don't need 2 of them. Is there an orientation where we can see that a little bit clearer? Well, maybe not. Yeah, I think you can see it. It's a little bit darker here. So there is something above these gold contacts. There is another shape. We have a gold contact and a silver contact, or at least silver in color, and a black dot looks similar to that stuff here. So, well, I have no idea how that works, but if you know how this kind of sensor is called, I don't know, is it a thin film sensor or something like that? Let me know. That's it. Thanks for watching.